Hello and good evening, everyone. Hope you are fine and enjoying your good days. We are now in the 6th week of our course, and I hope that you people are going through these video recordings as well as the courses material which we are sharing with you from time to time. And I have been sending various emails and messages as well on your internal email and internal messenger that please try to participate in your regular open classes. Try to answer the questions asked in the open forum. Also, the various assignments which are being distributed to you and the course reading materials which are being shared, go through them, ask any questions at any part of the stage, and I will be very happy to answer you. Now, coming to the today's lecture, the topic for today is the electric circuit. So now today we will see what do you mean by electric circuit, how it works, what are its different polarities, and what is its functionality. So first of all, coming to the description and definition of the electric circuit, we can define the electric circuit to be a set of interconnected components that use voltage, current, and resistance to perform a specific function. Now, it means that if I have to perform certain specific function, then the three basic components which are required for me will be voltage, current, and resistance. As we mentioned in the electric charge section, the direction of the electron flow is from the negative pole of the voltage source to the positive pole. So keep this thing in mind that whenever we are describing the flow of current, in other words, the flow of electron, the direction is always from the negative pole to the positive pole. An electric circuit must leave the positive terminal of the voltage source and flow through the entire circuit to finally reach the negative terminal gain. When the current flows in a certain direction and enters an electric or electronic component, the component absorbs the current. Now, it is a basic phenomena in our houses, in our buildings, shop, market, wherever we are using the electricity, and the electric current is passing through various components, whether small component or a bigger component, whether it is a small electric switch, whether it is an electric iron, or whether it's a washing machine, or it's an air conditioner, whatever the component we are using, it absorbs the electric current. Therefore, the terminal of the component through which the current enters is assigned the positive sign. So, plus will always indicate that terminal through which the current enters the circuit. You can take another convention or direction for the current flow, but you must also change the convention in the components that absorb the current. Now, this point is very important. For example, we say that the current is entering through the positive terminal in a circuit, and other way around, if I say that the current is entering through the negative terminal, Both options can be applicable. But in the second criteria, when I say that the current is entering through the negative terminal, then in that case, I have to reverse the polarities of the components that are absorbing the current. But in normal terminologies, whenever the current flow is identified, we see that the current which enters the circuit is always through the positive terminal. The basic electric circuit comprises a voltage source, a resistor, and an electric current. So in the figure 1, we will see a schematic diagram of a basic electric circuit. Now this is the basic electric circuit where there is a voltage source, there is a resistance, and because of this voltage source, the current is flowing in the circuit. So as you can see, the arrow direction, this arrow direction is coming out from the plus. So from the plus it moves, and again it moves through the plus towards minus into the resistance. That is how the current flows in the circuit. If for example I am to reverse the minus and plus, then obviously this resistance will also be reversed from minus to plus. So as we described earlier in the above last para, this direction of the flow of current is always from the plus into the circuit, and similarly from the plus into the any component. Now the resistance is basically any load, whether it is a small resistor, whether it is a machine, whether it is a big circuitry, whether it's a full home, everything here will be referred to as resistance. Now for a current to exist, the electric circuit must be closed. Now this line is again very important. The electric circuit must be closed. It means that if, for example, you can see this circuit, nothing is broken over here, then it means that the circuit is complete and closed and it will allow the current to flow through it. If the connections between the components are open, there would be no current. So if, for example, I see that there is a break in the circuit, the wire is broken or open, then there will be no current will be flowing through it. And therefore, it is not an electric circuit and is called an open circuit. Now, single pole, single throw mechanical switches can be fitted to control the circuit. Now let's come to another diagram, which is the figure 2. The figure 2 shows a schematic diagram of a basic circuit with a lamp in two states, switch closed and switch open. Now, for example, this is a circuit, and instead of resistance, I have a lamp connected over here. And there are two diagrams, but the same diagram, a voltage source, the current is flowing, and there is a closed switch. Now, there is a closed switch and there is an open switch. If there is an open switch, it means that the electric current cannot pass through this open switch. So there will be no light in this bulb. But on the other hand, when the switch is closed, the current passes through the switch and it lights the bulb. Now, when the switch is closed, the lamp turns on, and when it is open, the light turns off. Therefore, the switch serves to control the lighting of the lamp, just as we do in our homes in everyday life. Now, some devices are made up of semiconductors. They can emulate, that is, work very similarly to the operation of mechanical switches. Transistors is one example of the semiconductor devices. These are the devices that have several applications, and among them is that of emulating the operation of switches. So as we see a physical electric switch, similarly in electronic devices, we employ the transistors. So the transistors are basically small semiconductor devices, but they behave totally as the switches. The transistor receives the name because an electric circuit can schematize its operation with a very high transfer or transfer resistor or transistor. Figure 3 shows a schematic diagram of a transistor emulating a one-pole, one-way switch. Now, for example, if we see the switch, I can see this is a closed switch and I see this is an open switch. Now, actually, this is a symbol diagram of transistor. So as this leg is open, so I can say that it is a open switch, then no current can flow. But if it is connected, then it will become a closed switch and the electric current can flow. So the transistor is basically a semiconductor device, but it behaves as a switch in electronic circuits. So along with the transistors, I can have another device of the semiconductor family, and this is known as FET. FET or field effect transistor. So there are other devices made of semiconductor materials that can also emulate the behavior of the switch. And another example is FET or field effect transistor, which works with voltage contrary to the transistor. Now, how it works? So now we are seeing the working of the switch. When the current value exceeds a level, some devices, when the current value exceeds a level, some devices in the electric circuit may burn out. So we use fuses and circuit breakers. So these fuses and circuit breakers are electrical components that protect the rest of the components in the electric circuit. A fuse is a switch that blows or opens if the certain current level is exceeded. When a fuse opens, it must be replaced, while a circuit breaker can be reused since it recovers its basic function once whatever caused it to open has been eliminated. Both components work through the temperature produced by the current that passes through them. So because we know that whenever a higher current flows, the temperature goes up. Now the circuit breaker or the fuse, it is looking at the temperature. When it receives a higher temperature, whatever the scenario may be, it will get open. So when it is open, no current passes through it. When no current passes through it, so the heavy current cannot make the devices burn out. For example, our LEDs or any electric machine or any air conditioner, so they are saved from wearing out or burning out because of this fuse or circuit breaker. Now, cables are used to make connections between devices in an electric circuit. As we have seen, the cable between the voltage source and the bulb and the switch through which the current flows. The wires are one single conductive wire, while the cords are a set of conductive wires. The cords are more reflexible and resistant to various things, while the wire is more sensitive and can break more easily. So there are now basically two types of cables. One is the single wire and one is the conductive wire. So the conductive wire is actually a single connecting wire, as we have seen in the circuits above. But when we are talking about the conductive wires, they may be are the set of wires, and that is why it is given the name of cord. Now, as we have seen that the cords are more flexible and they are more resistant to various things because the conducting wire is actually not so strong enough to support a strong current. So in that scenario, we need the cords which do not break more easily. The cords also offer more resistance since it is a set of wires of greater resistance connected in parallel. Coming to the next thing, how important do we find these wires or the cords? And it is totally dependent on the gauges. The equivalent diameter of the wires or strands is handled under a standard called AWM. Now this AWM stands for American Wire Gauge. This is a parameter to check how the cable is strong enough to survive the heavy current if it passes through it. Some special applications we find in medicine and automotives, aeronautics, aerospace fields. They require special cables with other standards because they have to support a large and heavy current through them. All these materials offer some strength value. So good conductors, basically they offer minimal resistance, while good insulators provide very heavy resistance. We have discussed these things in the previous lecture as well, that what are the differences between the conductors and insulators. So conductors, we know through our previous understanding that they support a good amount of electricity to pass through them, whereas insulators are particularly designed to resist the electricity through them. Also, temperature is another parameter which affects the resistance value. The electric resistance of a piece of cable made of certain material as a function of its resistivity. Now, this resistivity is represented by the symbol. This is called rho. So this P symbol is actually called rho, R-O-W. It is dependent on the length of the cable, which is represented by small n, and the cross-sectional area of the conductivity, which is A. And it is given by this formula. So resistivity is actually, resistance is calculated with the help of rho L by A. Now, what is the difference between resistance and resistivity? So this point is important to understand over here. Resistivity is actually a property of every material. Every material which it withstands with the resistance. So resistance is basically its ability to resist the flow of current, and its property is known as resistivity. So resistance is basically dependent on these three things: the resistivity, the length, and the area of cross section. So if we go through these parameters, so as far as the length of the conductor is concerned, as the length increases, it means that the resistance increases, but it is inversely proportional to the area of conduction. As the area of conduction is less, the resistance is more. And if the conductance is, if I want to make more conductive, then the area has to be increased. Now, resistance increases with the value of the resistivity of the cable material and its length, and decreases as the cross-sectional area of the cable increases. The wires in the larger area have less resistance and can carry a more significant amount of current. Fuses are designed using these principles to determine the current at which they should blow. So it is particularly designed to withstand the current and resistivity. The voltage, as we have discussed earlier in the classes as well, or potential difference, it is measured relative to a reference value called the ground. The name earth originated because it refers to a metal bar buried in the ground, which is grounded in the ground. In houses, it is customary to connect the ground to the metal boxes of the contacts or the construction rods. Houses, electronic component, or electric appliances must always be connected to the earth ground. The reference ground is always concerned with the electric circuit and represents the value of 0 volt. So this thing is important to understand, that the ground is always referred to as the 0 volts. Now the ground is represented by these symbols. These are the three different symbols which normally are used in electric circuit books, but they all represent the earth or the ground. As a safety note, care must be taken when tampering with the electronic component, as the reference ground may be at underground potential. Electronic instrumentation equipment such as voltage sources, current sources, signal generators, oscilloscope, they isolate the ground from the reference ground and offer the possibility of connecting electric circuits to the ground. Now, some electric circuits require two power sources. As we can see in the diagram, there are two power sources and their common point is grounded. So an op-amp, this is a diagram of an op-amp, which is known as operational amplifier. It uses two power supplies. So one power supply is connected over here, second power supply is connected over here. Their common point is grounded, and its positive terminal is also grounded. And it is because it operates on the principle of differential voltage. So actually the two voltages which we apply, so this op-amp works on the difference of these voltages. So now till we have studied the different concepts of electricity, voltage, types of resistance, color coding scheme, all these things we have studied in this subject. Now I will again suggest you people, please go through all these recordings, get yourself well prepared, because in very few days your exams are in way, and I want all you people to have good grades in your marks. So as it was a lengthy discussion today, I will give you 3 open class questions over here at the end, so you can reply me as soon as possible. So the first question is, what is the difference between EMF, voltage, and potential difference? So normally these three concepts, they seem more or less to be the same, but there's a small difference between each three of them. So I want you to explain what is the actually difference between EMF, electromotive force, voltage, and potential difference. Coming to question number 2. What is the difference between BJT and FET? Now, in this topic, I was discussing about transistor. The other name for this transistor is BJT, bipolar junction transistor. And in the topic, we came across FET, field effect transistor. No, actually, I want to know both are the transistors, but please elaborate what is the difference between bipolar junction transistor and FET or field effect transistor. Coming to the third question in the continuity of these two, why is BJT called a bipolar transistor? As I have told you that BJT stands for bipolar junction transistor. So why is the name given to it as bipolar? So you have to answer these three questions as an open class forum questions, and I will be eagerly waiting for these solutions and answers of these questions. And also, please, in the previous slides and previous class lectures, do try to answer the questions. So thank you very much for today, and hope to meet you soon in the next class. Looking forward for any input. Thank you.